Okay, intermediate algebra, we're starting chapter 5, and this chapter is all about factoring and finding roots of quadratics. Before we factor any quadratics, though, we really need to practice factoring out common factors. If multiple terms can be divided evenly by the same number, that number is a common factor, and the largest of these common factors is called the greatest common factor. Now, the greatest common factor breaks down between coefficients and variables. For coefficients, it's the largest number that divides evenly into all coefficients. For the exponents, it would technically be the amount of the exponent that divides evenly into all of the exponents you see. In that case, it is the smallest power of the exponents shared by all of the terms. So if we look at number 1, 110x squared, 130x to the 5th, and 310x to the 17th. What number divides evenly into all three of these numbers? 10. So that is the greatest common factor of our coefficients. Now for our exponents, we look for the smallest number of the exponent that we see, x squared, x to the 5th, and x to the 17th. The largest value of x exponent-wise that we can divide evenly into those is x squared, because once an x squared goes into the 110x squared, there's no longer any x's left there to divide in. So our greatest common factor overall is 10x squared. If there are multiple variables, you just do it on a variable by variable basis. The numbers that divide evenly into 28, 42, and 63 is 7. A to the 5th, A to the 6th. This is an A to the 1st, which is the least number of A's. B squared, B to the 7th, B. So it's 7A, B. Now, finding a common factor is nice, but we have to be able to factor it out as well. Now, factoring it out means essentially we're putting it in front of the parentheses. We're like undoing the distributive property. And the distributive property multiplies something into each term, so if we're undoing that, we're essentially dividing it out. So when you pull something out front using factoring out the greatest common factor, like this 8x squared, it goes out front, and you divide both terms by 8x squared to see what remains. So 32x to the 4th divided by 8x squared is 4x squared, and 24x squared divided by 8x squared, the x squareds are gone, it's just 3. Let's see how this works in the problem. They start you with ones where they tell you what is factored out first. So I will start you in the same place. So 10y plus 350, the greatest common factor is 10. So the question is, what goes inside the parentheses? We have to divide 10 from each term. So again, the 10 is out front. What goes on the inside? Y. 350 divided by 10 is 35. So once you divide it out, that's what remains. Now on your homework, they may just ask for what's inside the parentheses, but keep in mind this is the proper form when you're actually factoring it out. Okay, so now we've got negative 63, a to the 7th, b to the 5th, plus 45, a cubed, b to the 8th, equals negative 9, a cubed, b to the 5th times something. So this is our greatest common factor. And usually, if the leading term is negative, they take the negative with it. So I need to divide both of these by negative 9a cubed, b to the 5th. See what's left. So the negative 9a cubed, b to the 5th is out front because it's been factored out. Negative 63 divided by negative 9 is 7. A to the 7th divided by a cubed is a to the 4th. The b's cancel. 45 divided by negative 9 is negative 5. A cubed divided by a cubed cancel. B to the 8th divided by b to the 5th is b cubed. So in total, once factored out, it looks like this. So now let's practice finding the greatest common factor ourselves. So first, write in factored form. What do z cubed and 3z squared share? They share a z squared. And if I divide it out from both terms, I'm left with z minus 3. So this is the factored form. 12t to the 5th plus 3t to the 4th. They share a 3 from the coefficients. Looks like a t to the 4th. Now, if I divide 3t to the 4th, 12 divided by 3 is 4. T to the 5th divided by t to the 4th is t. So 3t to the 4th divided by 3t to the 4th. You may think there's nothing left there. That's true that the 3's will cancel and the t to the 4th will cancel, but keep in mind, this is really anything divided by itself is 1. So when everything cancels, you need to make sure to include the 1 there, because it means something different if just 4t is there. I'll leave 5 for you to do. Let's talk about number 6. What do 23 and 67 share? They don't share any numbers, so it's just a 1. K to the 5th, and there's no k's here, so the greatest common factor is 1. You don't factor 1 out, so if you think the greatest common factor is 1, that means there is no greatest common factor in its most factored form for now. It's 23k to the 5th minus 67 if it's a binomial. So it's already in its factored form. Okay, let's look at some more. We'll do one of these. Let's do number 8. 27x cubed, y plus 18x squared, y squared minus 9xy to the 5th. These are all factors of 9. This has 3 x's, 2 x's, 1, so I need 1x. 1y, 2y, 5y, so 1y. So this is what I'm dividing everything by. The y's cancel here. 27 divided by 9 is 3, and we leave an x squared. 18 divided by 9 is 2. X squared divided by x is x. Y squared divided by y is y. And then 9xy is negative. 9 divided by 9, negative 1. X divided by x cancels. Y to the 5th divided by y is y to the 4th. So even though there's multiple variables, it's really the same. We're undoing the multiplication by pulling the number back out. Sometimes this is useful, particularly when solving equations for quadratics. Now, if you have 4 terms, often you can factor 2 sets, resulting in the same term being left over, and that common term, a set of 2 terms, if it's common, that itself can be factored out. Let's look at that AB plus 5A plus BC plus 5C. What do the first 2 share? Share an A. What do the second 2 share? They share a C. That means both sets of 2 share this B plus 5, which means this B plus 5 can be factored out, and then whatever's left goes in the other parentheses. That is A plus C. So the factored form of this is B plus 5 times A plus C. So let's start you off with how this should go. 3bc minus c plus 6ab minus 2a. So they've already started the problem for you by showing you what they share. So the first 2 terms share a c. The second 2 terms share a 2a. So they leave you with c times 3b minus 1 plus 2a times 3b minus 1. Because these 2 pieces are shared, this can be factored out. 3b minus 1. What's left comes together to your second factor. So that means c plus 2a is your second factor. Let's try this again. 5j squared k plus 10j minus 20jk minus 40. Looks like 5j was factored out of the first 2, and a negative 20 is factored out of the second 2. So again, what is my common factor? jk plus 2. And what's left becomes my other factor, 5j minus 20. Now, you can technically factor this further. What do 5 and negative 20 share? A 5. So if you pull a 5 out front overall, divides by 5 here, you end up with j minus 4. This would be more proper, so just keep that in mind when you're doing this. And we will continue in the next video.